Hello everyone, welcome to the solution of LeetCode problem 103 named binary tree zigzag level order traversal. In this problem, we are given the root of a binary tree. Now we have to return the zigzag level order traversal of its node's value. Suppose in the first example, the traversal will look like first level contains the element 3. So we will store it here. In the second level, 9 and 20, instead of going left to right, we will go right to left. So it will become 20 and 9. 21st, then 9. And into the third level, instead of going right to left, we will go left to right. It will become 15 and 7. So we have to return this zigzag order traversal pattern of this given route. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to solve this problem, we have taken this example. Here, the root is 5, which has two children, 3 and 6. 3 has two children, 1 and 2. And 2 has two children, 1 and 1. Now, we have to return the zigzag order traversal pattern. So, we will return at first 5. Then, we will return 6 and 3. Then, we will return 1 and 2. Then, we will return 1 and 1. Now, as we have to return the levels, we will using breadth first search algorithm to solve this problem. Now, the basic intuition behind the solution is, if any kind of problem we have to deal with the levels, basically we will use the BFS algorithm. And BFS algorithm utilizes the advantage of the queue data structure. So we will take a queue here to solve this problem. So now let's see how the BFS basically works here. For the first level, initially our traversal starts from the node 5. So we will store the node 5 into a temporary vector. Now this is the first level. So we will store the 5 into a resultant vector and remove the 5 from the queue and as well as from the small vector as well. Now 5 has two children, 3 and 6. One is left, another is right. So we have to insert 3 and 6 here. Now 3 and 6 are the second level node. So what is the top element of the queue? It is 6. So we have to insert 3 here. Sorry, it is 3. We have to insert 3 here. And we have to remove 3. Now, after removing, we have to check does 3 has the left and right children or not. Yes, it has. So we have to insert 1 and 2 into the queue. Now, what is the top element of the queue? It is 6. So we have to insert 6 here. Now, the second level traversal is completed. So we have found 3 and 6. Now, our queue element is 1 and 2. What is the top element of the queue? It is 1. So we have to insert 1 into the queue. And 1 does not have any of the left and right children, so we don't have to add anything to the queue. Now our current element is 2. So we have to add 2 to the small vector. But 2 has left and right children, which is 1 and 1. So we have to add them and remove the element 2 from the queue. Now, our smaller vector element is 1 and 2. So far, so good. Now we have completed iteration in the 3 level. Now let's see what is the iteration of the final level. So here, the top element of the queue is 1. So we have to add 1 to the temporary vector. Now 1 does not have any of the left or right children, so we don't have to add anything into the queue. Then we have to remove this one. Now again, the top element of the queue is 1. So we have to add this 1 to the temporary vector and add both of the 1 and 1 into a resultant array and remove this 1. Now our iteration is completed and we have found this array. So here, as this is an array, it will have the index number 0, 1, 2, and 3. Now what if I swap or reverse the order of the odd index number value? Now, if I reverse the order of the odd index value, it will become 5, 6, 3, 1, 2, and 1, 1. Here, 5 is from left to right, 6, 3 from right to left, 1, 2 from left to right, and 1, 1 from right to left. This is the resultant output. And this is how basically we're going to solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named Zigzag level order, which is a tree as a parameter. Now we are taking a two-dimensional vector answer to store the order. Now, if the root is null, we have to simply return answer. Otherwise, we have to take a queue, and initially we have to insert the root element to the queue. Now we are running this loop until the queue is not empty, and in each iteration we will calculating the queue size and taking a temporary vector current. Now here we are running this loop until queue size becomes 0, and inside each iteration we are inserting the front element of the queue into a variable x, and we are removing the front element and inserting its value to the current vector. And here, if the front element has a left subtree, we are inserting the left node into the queue. Again, if it is a right subtree, we are inserting the right node in the queue. Finally, we are inserting the current vector to the resultant answer. And here, we are iterating to the answer vector, and if the index is odd, we are reversing the corresponding order. Finally, we are returning the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.